Here we got day two. Day two, we're taking it one step further with compound inequalities. So if you think about what compound means it involves a little more.
So then we're going to need to define conjunction and disjunction and find out what the difference is. But let's start with compound statement made up of more than one equation or inequality. So then a disjunction is a compound statement that uses the word or. So its disjunction is x is less or equal to -3 or x is greater than 2. So the interval notation is negative infinity, comma, -3 or 2, comma, infinity.
Well, one thing we want to make sure we're 9 times out of 10, your graph for a disjunction or an or compound statement will look like this, where they shade in opposite directions. Once in a blue moon, you will get where you shade from a given point this way, and then you also shade from a given point this way. And if that happens, then what this ends up being for a solution would be what we call all real numbers. It's my double bar R. It's every number out there, simply because an or statement does not have to be true with one. It can be one or the other, or it can be both.
So then we go on to conjunction. A compound statement that uses the word and. So conjunction x greater or equal to -3 and x is less than 2. So our interval notation is a square bracket, -3, comma, 2, bracket. Just a side note, a conjunction is true if and only if.
Oh my gosh, we have a biconditional. We're bringing flashbacks to geometry. That's a little too bad. Have fun with it.
If parts are true. Conjunctions can be written as a single statement as shown. X is greater or equal to 3 and x is less than 2. So then we could have -3 is less or equal to x and x is less than 2.
So the big catch here is when you see an and, since they both, all of the parts have to be true, that means that it will either be like this, where you only shade in the middle. The other way might be is if, and this is a rare occurrence, I wouldn't assess you on this, where you graph from here over and from here over, and because it has to be an and, where it means it has to be where they're both true, where the highlighting overlaps, this would be a situation where I would just simply write a circle with a line through it, which means the null set. It simply means that there is no part of this that is true. So let's go ahead and try some. So we have to solve these and then graph them. We solve them independently like we normally would. So -3, we get x is less than -1. Here we divide by 3, and we get x is greater than 3. So we know that our numbering has to go as far as -1, 0, 1, 2, 3. And we see here that we have both less than and greater than signs, so we'll have an open circle at -1, an open circle at 3. And it says x is less than -1, less than is this way. X is greater than 3 this way. One thing you cannot forget in your solution, though, is the word or. I will dock points if you just give me the inequalities and don't include that it's a disjunction. Now we look at one that is an and. We still solve it the same way we were. Here we're going to divide by -2. And when I do that, I'm dividing by a negative, so I flip the sign and I get x is greater than or equal to -4. And we add 3, and we get x is less than 5. So when we number, I'm going to go -4, -2, 0, 2, 4, 6. Yes, if you have to extend your number line, please feel free. So then we go -4 has a closed circle because it's greater than or equal to. X is greater than, less than 5, so we'll have an open circle. If we were to highlight 4, this says it's going to go from, it's greater than, so we're going to highlight this way. and this is less than, so we're going to highlight this way. Do not highlight outside them. I like to draw my arrows just so I can see, but in reality, we're going to highlight here because that's where they're both true. Outside the less than -4, greater than 5, that is not true for the other one, so because it's not true for the other one, we can't include it. And hold on, I want to make sure I read my instructions correctly. Here we have an interval notation, or a conjunction, and if I was looking at it with just this, I would add 4 and add 4. But, as I erase this, if I were looking at it as just this, I would still add 4, add 4. So when you have a conjunction that's written all together in one statement, you're going to, whatever you do to solve the equation, you're going to do that everywhere. So now I've got 14 plus 4 is 18, less than or equal to 6x, less than or equal to 24. Now I'm going to divide by 6 everywhere, just like I've been doing, and I get a final solution of 18 divided by 6 is 3, less than or equal to x, less than or equal to 24 divided by 6, which is 4. So when I do my inequality, or my graphing, I'm going to do my 3 here, I'll do my 4 here, just to space things out a little bit. And both of them are going to be closed circles. So we got a closed circle here, and a closed circle here. And as it shows in here, x is in between my numbers, so we're going to shade in between my numbers. The last piece we have is going to be to write the inequality. The catch here is in interval notation. So that takes us back to, here we know we have an x. We only have one dot, and that's a 2. And so I'm writing it initially, the inequality. And so this would be less than or equal to, because it's a closed dot. So I look at it, when we look in terms of interval notation, we're going from negative infinity, because this keeps going, all the way to 2. 2 is going to be a square bracket, infinity has to be an open bracket. So this would be my solution. E, now I see that my highlighting is in between -2 and 0, so my interval goes from -2 to 0. It's an open bracket at -2 because the circle is open, and closed at 0. Finally, the last one, we see that they're shaded in opposite directions, so I know that this is going to be an OR. It goes from negative infinity, which has to have an open bracket, to -1, which also has to have an open bracket due to the open circle. And then it starts back up at 3 and goes to infinity. Infinity needs open bracket, 3 has an open circle, so it's also an open bracket. If you want to get fancy, you could also use a U for union of the two, but it is not by any means required. So now I want you to try some stuff. We want you to solve and graph these on a number line, write your solution in interval notation. Got those two. And then we've got this one where I want you to write the inequality in interval notation that matches the graph. If I know that infinity is something you can't write in Edpuzzle unless you have a math keyboard. So what I need you to do is you can just write the word infinity, and if it's negative infinity, you can put a little negative sign in front of it. And as always, bring your questions to the class.
A reminder on G that you need to do it to both sides, not just one.
Yes.
When simplifying that down, we need to do it to both sides.
Remember, that is a conjunction, not a disjunction.